All right, folks, let's talk about U-substitution. Now, in this class, U-substitution is kind of your last resort. So you're only looking at a few cases where you're going to need to use this in AB calculus. So let's take a look at a few cases when you'll need to use this. Otherwise, you should use some other simpler method like reverse chain rule or something else that will work a bit easier than U-substitution. Okay, so let's take a look. All right. So what you're really going to look at here is you're going to look at things that have a radical in this course. So if you have a square root, then and you can't use a simpler method, like you can't just put the power to the 1/2 and then divide some things out or simplify or use reverse chain rule. If you don't have the hook, then you're going to need to use U-substitution. So this really should be your last resort, U-substitution. And what you're going to do is, the basic idea is you're going to make whatever's inside the square root, you're going to call that u, and then you're going to solve for x in your little substitution there, and you're going to take a derivative, and we're going to substitute for dx, and then we're going to now do the integral in terms of u. So it's kind of a longer process than all the other methods that we've used, but it's the only one where you'll have to do something other than a simpler antiderivative method or a reverse chain rule. So the only other method in AB calculus is U-substitution. Let's take a look at some examples here. So if we look at this one, the integral of x square root of x minus 1, we can't do reverse chain rule because the inside, if we took the derivative of x minus 1, the derivative of that is 1, and we have an x out here, not a 1. So we can't use reverse chain rule because we don't have a hook. So what we're going to have to do is we're going to have to use U-substitution because we notice we have a square root. The only other time I could see that is if you have like a cube root. Maybe you might want to use U-substitution as well, but for the most part, you're only looking at, like in this class, really square roots. So let's take a look at how we would do this. So on the side here, I'm going to substitute u equals x minus 1. All right, and then I'm going to solve for, x. And then I'm going to take the derivative of each side. So I'm going to have the derivative on this side is du, and the derivative of x is dx. All right, so that's nice and simple there. All right, so then what we're going to do is we're going to make our substitution. So we know that x is u plus 1, so I'm going to substitute that right there. And we know that the whole integral is just u, so I'm going to substitute that. And then I'm going to substitute du for dx here. I got a fly right in my face here, guys. So I'm going to have u plus 1 times u to the 1/2 du. And now I'm just going to integrate this guy. So I'm going to do distribution, and I'm going to have u to the 3/2 plus u to the 1/2 du, and I'm going to have u to the 5/2 because I have to add 1, right? U to the 3/2, again I'm going to add 1, plus c, and then the last thing, this should be 5/2, guys. And then the last thing that I'm going to do here is, instead of u, I'm going to put back the x. So I got to put back what I had here to begin with back and resubstitute it in for u. So I'm going to have x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c, and that will be my answer for that one. All right, so U-substitution is a little more complicated because you got to go and you got to do your little substitution there, then you got to substitute, you got to do integral, and then you got to resubstitute back in. But you know, it is what it is. That's why we're going to try to only use it as a last resort if we see some square roots that we can't use the reverse chain rule. So let's do one more example here. So in this case, again, the derivative of 2x is 2. So I don't have a hook on the top, instead I have an x. And you'll start to notice that I'm going to end up with x's and roots when we're looking at U-substitution. So I'm going to rewrite this guy. Actually, I'm not going to rewrite it yet. I'm going to do my U-substitution first. So u is 2x minus 3. I'm going to solve for solve for x. And that's going to give me, let me split this guy up here. 1/2 u plus 3/2. Oops, that was a plus. Ooh, I nearly messed the whole thing up. Minus 3/2. Okay, then I'm going to take the derivative. The derivative of 1/2 u is 1/2 du. And that derivative is 0. Derivative of x is dx. And then I'm going to make all my substitutions. Sorry, guys, they're a little loud out there. So, 2x minus 1. This is going to be a little tricky. What I'm going to have to do is I'm going to go 2, and I'm going to have to substitute in for x right there. So I'm going to have 1/2 u minus 3/2 minus 1 all over. This is just going to be u to the 1/2, right? All right, then I got to simplify, and then I have 1/2. I also don't want to forget that I have to substitute there and for dx, so times 1/2 du. All right, so now I got to do some simplifying in order to do this. So 1/2, I'm going to put the 1/2 out in the front there. And I'm going to get, let's see, I'm going to multiply this in here. And I'm going to get u. I'm going to get u minus 3 minus 1 over u to the 1/2 du. And I'm going to split this u to the 1/2 to all of these here. Oh, actually, before I do that, let me do minus 3 is minus 4. Okay, so now I'm going to split the u to the 1/2 to these two guys there. So I'm going to have u over u to the 1/2. So u over u to the 1/2 minus 4 over u to the 1/2 du. So u is u to the 1, and I'm going to subtract the exponents, which is going to give me u to the 1/2 minus 4 u to the negative 1/2 du. All right, so now that I have it all simplified, I can now do my anti-differentiation. So I'm going to have u to the 3/2 over 3/2 minus 4u to the 1 minus 1/2, because I'm going to add 1, right? So it's going to be 1/2 over 1/2 plus c. And then, of course, the last thing that I have to do here is I have to substitute and simplify here. So I'm going to substitute the u back. What was u again? 2x plus 3. So I got to put that back here. So I'm going to have 1/2 times 3. It's going to be 2/3. And that was 2x plus 3, I believe. Yep, 2x plus 3 to the 3/2 minus 4 times 2 over 1. 2x plus 3 to the 1/2 plus c. All right. Your eyes aren't tricking you. I forgot my parentheses here, so I put a parentheses around that. Okay, so then my very last thing is I'm going to do this 1/2 times each of these here, and that's going to give me 2/3 2x plus 3 to the 3/2 minus 4 times 2x plus 3 to the 1/2 plus c. And c times is 1/2 c, but that's still a constant, right? So I'm just going to leave it as c. So here's your answer. So once again, u substitution is a bit more complicated because you got to, like I said, you got to substitute the u, you got to do your little math here, and then you got to do substitution. You got to simplify, and then once you simplify, you got to do your antiderivative. Then you got to substitute back. So a little bit more work to do, but it is pretty straightforward in what you have to do and when you're going to use it in terms of the very rare case, their last resort, when you're going to use U substitution. All right, guys? All right, there you go. U sub. Bye.